Welcome to the Big Data Learning. In today's lesson, I want to talk about YARN. YARN stands for Yet Another Resource Negotiator. YARN is part of the Hadoop ecosystem. It's an Apache open source project. Let us understand the reason for YARN. If you can recollect from Hadoop 1.0 architecture, the job tracker was doing resource management as well as application scheduling. So that's a single point of failure in Hadoop 1.0 system. Yarn came up with the primary goal of separating these concerns, which are related to resource management and application execution scheduling. So the way the architecture has changed from 1.0 to 2.0 is that MapReduce became an application for Yarn. So you can think of a layer being segregated from an application and pushed down to the platform. So in Hadoop 1.0, this is just one component doing MapReduce as well as the resource management and application scheduling and execution. I will show you how the architecture has changed from 1.0 to 2.0 in a minute. Before that, what Yarn brings by this big change to the architecture? So Yarn is a very powerful concept because it brings in the other application paradigm to the platform. So some of the best examples are Storm, Spark, and few more in the development. Storm and Spark are also from the Apache open source project. It's part of the Hadoop ecosystem with different problem solving approach for big data processing. One is a low latency, the other is a in-memory MapReduce processing. So with this change, like MapReduce, any application can request for a resource to Yarn. So the resource request could be like a CPU or memory cycle, and few more resources that it requires to do the data processing. So don't worry if you have your application already running because Yarn is backward compatible. And also it brings a better integration with diversified application needs. Right? So let us go to the architecture diagram and I can quickly show you the difference. If you look at the left hand side of this particular diagram, this is 1.0. The underneath file system is same in 1.0 and 2.0, which is HDFS. What has really changed is this particular middle layer. So in 1.0, the MapReduce, resource management, plus job processing, all were handled by this particular component, and the other higher level abstractions like Pig, Hive, I'm sorry, there is a typo here. It could be like other application. So in 2.0, what they have done with respect to architecture is to reduce the burden on this particular MapReduce component and separate the resource management and application scheduling to a new component which is nothing but Yarn. So what happened to the MapReduce which was associated here? That got pushed up as an application on top of Yarn, like the way you see Pig and Hive and others sitting on top of this particular layer. Right, so that's an architectural overview of Yarn. Let's deep dive into Yarn's internal components. Yarn has five major components, right? One of them is a resource manager, second is node manager, third is the application master, fourth is the container, and the final one is the client. We will talk about each of these components to a level where you could relate the concepts of Young and you could understand the concepts of Young, right? The naming conventions are pretty good here because you could directly make out, from the name what it is doing. For example, resource manager. So the resource manager is solely responsible for allocating and managing resources available within the cluster. So there is only one resource manager per cluster. In a practical scenarios, it may be running as a dedicated instance in a cluster. So its job is to just allocate and manage resource, right? It's pretty simple. So what happens with node manager? Node manager is responsible for local resource management. It is also the node local representative of the RM. This is per node. So what it means, in your Hadoop cluster, if you have 10 different nodes, 10 different data nodes, so each of them will have a node manager. And this represents the actual node resource management, right? Remember, the resource manager is responsible for allocating and managing resources available within the cluster. But this one is just for the node. What is application master here? This is the third important component within the Yarn architecture. So this is an encapsulation of all application specific logic and libraries, right? So the application master is actually responsible for negotiating the required resources from the RM and working with the node manager to execute them to completion. So let me put it simply. The application master makes a request to get some resource allocated by resource manager. But then once the resource is allocated by RM, the application master directly works with a node manager to execute the task to completion. So what this means is that application master is per application based. So this particular daemon is running at application level. What is the fourth one doing? The container. The container is nothing but an abstract representation of a resource that is given to a particular application. The AM is a specialized container that is used to bootstrap and manage the entire application's lifecycle. Right? So the last one is the client. So this is the entity in the cluster that can submit applications to the resource manager and specify the type of application master that needs to be spawned to execute the application. So here is the flow, guys. The client makes an application to resource manager and tells what type of application master it needs to execute the application. Once the application master is spawned, when the job is submitted and it gets the resource from resource manager, then it talks to the node manager to actually execute the task. Okay, so the resource manager has two different main components, or two key components. One of them is a scheduler and the applications manager. The scheduler is responsible for allocating resources to various applications. And the application manager is responsible for handling application submissions made by clients. Right? So the application manager receives the request from the clients, and then the scheduler works in conjunction to allocate the resource to various applications. It has three different interfaces. This is also important to understand because two of them are public interface and one is an internal private interface. One public interface for clients to submit jobs using application client protocol. Another public interface for application masters to request for resources, which is application master protocol. And a third, which is a private or internal interface for node manager interactions. So the brain behind the resource manager is actually getting the request and then talking to the application master for resource requests, and then it also talks to the node manager, right? So what is the AM request to RM? What does it contain? So it could actually have a number of containers that will be required. For example, 100 containers, right? The specification of resources in each container, for example, 2 CPU and 4 GB RAM, etc. So the locality preferences for the container at the node or rack level, you can actually prefer. You can actually decide the locality preference for the container, whether you want it at a node level or rack level, and the priorities of requests within the application. So these are maybe part of the application master request to resource manager. The resource allocation is dynamic and agnostic to the internals of the application. So what this means, when the resources are allocated, it doesn't deal with any of the application specific requirement. It doesn't know what the application is going to be or how it's going to be, right? So in the scarcity of resources, the other way is also possible. RM can request AIM to release. So the resource manager can say application master to release some of the resources because it's running out of the resource, right? For example, it gives a warning before it sweeps away some of the resources that are being used by AIM. So the application master actually negotiates a container with a scheduler. Remember that the resource manager had two different components. One is the scheduler and the application manager, right? So that's a primary job of the application manager. The container is usually used to bootstrap the application master for this particular application, right? Once the application master spawn, the application master will periodically send heartbeats to the resource manager, because it has to report whether the application master is alive and also it has to request resources for the application, right? One good thing is in Yarn, the resource model follows the concept of late binding, which means it is not it is the resource is not being used at the time of allocation. Only when it is assigned, the resources are bind. The resources are tied, right? That's why it's called late binding. Let's see what is node manager. The node manager is nothing but a local container management. So things like authentication to or resource monitoring, right? So it will also report to the resource manager using heartbeats, and it uses container launch context record. This is to specify the container metadata like dependencies, data file paths, and environmental variables, right? So based on this CLC, based on this container launch context only, the network manager spawns a container. So as it is responsible for spawning, enums are also responsible for terminating the containers either on request by the application manager or on decrease from the resource manager. Okay, there are two ways possible. And it also, and this is an important point to understand, and the node manager is the one which is actually monitoring the local physical resources such as CPU, memory, and disk health, and any services that are associated with the node manager. So the node manager has the actual resource status with it. Node manager also provides other services like it could actually give a log aggregation to the application, right? And it's possible to add some auxiliary services to the node manager. So there are ways to do it. In this video, we are not going to talk about them. So what is Yarn client? So the Yarn client is responsible for submitting an appropriate CLC for the AM. So the CLC is nothing but the container launch context, which we just talked about it. So this is nothing but the metadata, that's just like dependencies and data file paths and environmental variables, right? So the AM itself runs a container whose resources are negotiated by the resource manager. Registering the AM is also the responsibility of the client. The client is free to provide other services to its customers, to consumers, right? So its main job is to submit the appropriate CLC for the AM. That's it. So developing Yarn applications. So what has brought in the Yarn change in the Hadoop is that it allowed other programming paradigm like Storm. Storm is a real-time stream processing engine that has been ported onto Yarn, bringing in the capability of moving data to compute nodes. So when the data is constantly coming into your Hadoop cluster, you want to be able to use Storm. So these days, to give an example, so when a user browsing some information on the internet browser, so you want to be able to push the relevant advertisement or relevant, relevant pages almost in real time. So you can't wait for some offline data to be accumulated, aggregated, and then processed, and then send the appropriate, information. So it has to happen almost, real time, where the data is continuously coming into the cluster. So this is one, and the Spark is the another project that is on Yarn, right? So the Spark is very, very fast because it uses the in-memory to do the MapReduce task and data transformation as well, and it can leverage the existing Hadoop infrastructure. So in this line, there could be many more, in the future. So for this tutorial, for this video, I am winding up with this applications. I will come back with more videos later. Thanks for listening and watching. Bye.